Well, I am here with Nir Stoff from the World Meteorological Organization. Sir, thank you very much for taking time to talk with me here today about the future of weather forecasting and how it's kind of changing in with AI models becoming much more prevalent today. First off, sir, do you mind introducing yourself and where you are joining me from here?
Yeah. So I'm sitting in WMO, which is the World Meteorological Organization. The headquarters sit in Geneva. And we are the organization that helps coordinate the work of meteorologists all around the world, be it in modeling, like the talk we have today, or in measurements and satellites, and all those things. But we are only the secretariat sitting here in Geneva. Actually, WMO is a network of the meteorological services around the world. So wherever you are, you have the National Meteorological Service. It is a part of the WMO community.
And it really is. I do have to give a shout out to the WMO because it's one of those just like global organizations that everybody partakes in, and it's absolutely incredible what you guys do. So you are the people I want to talk to about the changing and the future of meteorology, and specifically related to AI. So I'm going to put the first question, the basic question out there. So when we talk about AI weather models, a lot of people they see AI and they imagine Chat GPT or something like that. But what is an AI weather model and how does it differ from your classic numerical models like the GFS or the ECMWF or anything like that?
So actually, there are various types of AI models, and some of them may look like the Chat GPT thing. At the end, you might work like that. So at the end, you might have some Chat GPT that you will ask, should I take the umbrella now that I'm going to walk with the dog? Or not, and you'll get an answer. But we are not there yet. So the current models are trying to do something very similar to the regular models, and that is to simulate what will happen in the atmosphere. So we have what we call the grid. That is, you take all the data and spread it in equal distances around the globe and various levels. And you have temperature and humidity and wind and clouds and all those atmospheric components. And then the weather models simulate it, say, okay, if this is the situation now, what will happen in the next step, and then next step, etc. And then you try to go to the next days and maybe even next weeks, right? So and up to now, all this modeling or simulation of the atmosphere was done by using equations, the equations of physics, Newton laws or whatever, fluid dynamics, all those thermodynamics, all of them are there inside, and they are crunching those numbers and producing the forecast. What AI does is that AI doesn't know physics. So it's a different approach, and that's you may call it more a statistical approach, because what AI is trying to figure out the statistical relations actually between what's happening now and what happens after a while and what happens next. So the methodology is to try to get in as much as data as possible about the history. This is called the training period of an AI model. You feed it with, this is what happened, and then this is what happened 6 hours later, and this is what happened 6 hours later, and then the next day, this is what happened, and that is what happened 6 hours later, etc. And in that way, the system learns from those things, and it's intelligence in a way that is very similar to the way our brain works. Because when we try to understand the world, we don't do it with equations, right? We have, a network inside our brain that is doing exactly the same type of mathematical calculation and is learning from experience, right? So that's what the AI models are doing. But actually, when you learn from experience, you learn physics, not explicitly, but implicitly. For instance,
Mm.
everybody knows that if I take a ball and leave it, it will fall to the ground, right? We know it from experience and not from then. Of course, if we are a student in university, we know to calculate how fast it will move, etc. But the AI methodology is similar to that, and it is already producing very accurate forecasts.
And I guess that is my follow-up. Well, 2 follow-ups there. So it learns. So if it gets something wrong, does it learn like, okay, next time I should do it this way? So, for example, if you have a storm going in one direction, but it actually goes in a different direction, does the AI see that and go, okay, in the future, I know that if this happens, this happens. Is that what you're kind of saying here?
Actually, yes. So it learns from errors. Actually, it has something that is called a cost function. That is, you tell it what is right and what is wrong, and then it starts to adjust its inner. It's called weights. The inner calculations to try and reduce the cost, to try to reduce the errors. And if you give it a good, definition of what error is, then the mathematical model or the system will gradually get to a better and better result. That's the essence, and you can retrain. So it you got to something, it works, but then you have a new data set, you can retrain, and then it will improve.
So I guess the elephant in the room, the big question is, how does this match up then against numerical models like the classic, the old school models and the AI models? Have you seen it being better? Because I have seen some of them are kind of getting pretty good at like tropical weather forecasting. There's some evidence there. What have you seen from the role of WMO? Has the new models, these AI models, made a difference in how we forecast, and is it more accurate?
So yes, so this is of course one of the things what we are trying to do. And as I said, we is not a group here in Geneva, but a group of meteorological experts around the world that are sitting and trying to understand that. Um, and what would the current understanding is, those models are capable of getting very good results, sometimes better than what we had before. Um, the second thing, and maybe it's the most important one, is that they are able to do very accurate forecasting with very small computational power. That is, the amount of computational power needed to run a global model simulation of the entire globe is several orders of magnitude lower. So it could be tens of thousands time or even 100,000 times faster
Wow.
calculation than the typical numerical weather prediction, which means you could run a global model on a PC.
Wow.
Up to now, you needed some supercomputer in some sophisticated data centers to run them. And now, in this new technology, you can get comparable results with very small or computer resources. And that's maybe the magic here, or the fascinating aspect. We see it outperforming regular models in some aspect, but not in all of them. So, for instance, you talked about tropical meteorology. So one of the things we see that the track of hurricanes are actually forecasted better by the AI systems, uh, while the intensity of the hurricane and the amount of precipitation is less accurate. So we still need to understand why and how, but it's already being used. So once we understood that the tracks are better, now hurricane centers, etc., look very seriously on those tracks.
That's interesting. Speaking of tropical, then, so because tropical meteorology is not just local to one spot or another. In the United States, I feel like it's very fortunate that we have hurricane hunters, a lot of balloons that get launched, but that's over land. So out over water in the middle of these very data sparse areas, numerical models, from what I understand, they need good initialization, those original factors to make them kind of more accurate. Does the AI model need that? Is this a little bit different in, like, especially those data sparse areas?
So as far as we understand today, and still this is under research, like any other model, garbage in is garbage out. So if you don't feed them with good initial conditions, etc., you cannot get good results. So there's no magic there. Uh, they are more efficient, calculation. But if you don't have data, you cannot forecast.
So I know this is a emerging technology, and I'm kind of going to put you on a spot here. Where do you think this technology with the AI models will be 10 years from now? And it doesn't have to be exact, but just kind of like, what are your general ideas? Is this going to be the future of meteorology forecasting?
Well, this is very risky
Mm,
prediction. So, I was a forecaster, so I'm very cautious when giving predictions like that. Um,
absolutely. I
but
understand you.
still, it seems that it's going to be our future. It seems it's evolving so fast, and there's those possibilities. And but the major, I think, change is going to be actually in the delivery of the service, not only on, when we talk about the models, etc. It's the back office, and the big change is going to be, I think, in the front end side of things. You can produce today, as you said at the beginning, a chat GPT that you ask questions, right? So, as I said, you will be able to have an application where you will ask questions and get answers automatically.
Wow.
You will be able to get the answers not only in text, but also in video, right? So, you know that you already have those AI applications that give you images, videos, but the videos don't need to be, horses riding on the seashore. It can be a forecaster standing in front of you and
Whoa.
giving you the forecast, right? So think about that kind of a
I got to
future.
start thinking about my job here. Yeah. Like,
Yeah,
goodness.
all of us probably need to. Yeah.
Wow. Well, it really is interesting talking with you on this. Just the way AI is evolving so much. Something I always say, and I know you're the expert in this, but something I always say is like, today is the worst it will ever be, in the sense that tomorrow it's going to be better, right? It feels like this technology is changing so fast. So it's really important to talk to you about this. So thank you very much for taking time with me. Last question I do want to ask you is there any resources via the WMO people could learn more about this? And do you have anything new at the WMO coming out that you would like to share, since you're talking with me here right now?
So at the WMO, the really our effort is on working with the community of experts to understand, because we don't want uh, forecasters around the world to start using tools that are not accurate enough. They need to know what is available. They need to know how to use them, when to use them, and when not to use them. So actually, for a professional, this is a very interesting work, and I really So we have webinars and we have technical meetings, etc. And I really encourage meteorologists and experts to join those events. We just had an event in September. A gathering, with the tech companies, with the meteorologists, talking about how to work together and do those synergies between the private and the public sectors. We are starting a webinar series, etc. So there's a lot to follow, and there will be probably fascinating things happening.
Well, all right. Well, thank you very much for taking the time to talk with me. Then it is all very fascinating to me. So I appreciate your time, and yeah, I hope you have a great day.
You too.